Today we're going to talk about integration by substitution and the general power rule. We learned last section that the integral of x to the n dx is equal to 1 over n plus 1 times x to the n plus 1 power plus some constant of integration. But what if we had a more complicated function? What if we had something like we wanted to find the integral of 2x times x squared plus 1, all that cubed, dx. How would we even begin to do that? Well, we could maybe try something like this. We know if we're going to take an integral, it's the opposite of a derivative, so let's consider the derivative of x squared plus 1 to the fourth. If we take the derivative of that, we use the chain rule, and we get 4 times x squared plus 1 cubed times 2x. Well, that's looking really good because we have a 2x here, and we have a 2x there, and we also have the x plus 1 cubed here, and the x plus 1 cubed there. All we have is this pesky 4, but we can get rid of that pretty easily if we let our function be x squared plus 1 to the fourth divided by 4. Well, now if we take the derivative of that, it's going to work out to be x squared plus 1 cubed times 2x, which is exactly what we wanted. So this tells us that the integral of 2x times x squared plus 1 cubed dx is equal to x squared plus 1 to the fourth over 4 plus some constant of integration c. And the reason this works out really nicely is because this 2x here is the derivative of this other part of the function of x squared plus 1 cubed. So we can let this be, say, u cubed, and then this here is our du. And that leads to this really wonderful idea called the general power rule. Let me switch back to black. The general power rule is as follows. The integral of u to the n times du dx, so the derivative of u with respect to x, dx, so the integral of this guy here times dx, is the same as the integral of u to the n du, which now we can apply our standard power rule. That's 1 over n plus 1 times u to the n plus 1 plus some constant of integration c. Let's take a look at just a couple of quick examples. So let's say we have the integral of 3 times 3x minus 1 to the fourth dx. Well, we see here we can let u equal 3x minus 1, then du dx is just 3. So then this integral here can be rewritten as the integral of 3x minus 1 to the fourth times 3 dx, but that's just the integral of u to the fourth times du. And so now we get 1 over 5 u to the fifth plus c, and now we just write everything in terms of x. Remember, u is 3x minus 1, so this is 1/5 times 3x minus 1 to the fifth plus c. One more example. Let's say we have the integral of 2x plus 1 times x squared plus x dx. Let me switch over to blue. So here we let u equal x squared plus x. So then du dx is just 2x plus 1. Hey, that's really handy because we have a 2x plus 1 here. So that tells us that du is 2x plus 1 times dx. So this whole integral here can be rewritten as the integral of x squared plus x times 2x plus 1 dx. But this part here is just du, and this part here is just u. So this becomes the integral of u du, which is 1/2 u squared plus a constant. And now we just write everything in terms of x again, and so we get 1/2 u was, let's see, x squared plus x, so we have 1/2 x squared plus x squared plus c. All right, let's take a look at another example. We have the integral of 3x squared times the square root of x cubed minus 2. So let's go ahead and rewrite that in exponential notation because integrals work a lot nicer in exponential notation. And so we get the integral of 3x squared times x cubed minus 2 to the 1/2 power dx. Now if we pay attention, we'll see that this part here, we can let that be u. And so then du is 3x squared dx, which is really handy because we have a 3x squared right here. And so this integral can be rewritten as the integral of x cubed minus 2 to the 1/2 times 3x squared dx. But again, this part here is just our du, and this part here is u to the 1/2. So we get the integral of u to the 1/2 du. And so if we apply our standard power rules, we add 1 to the exponent, so we get 3/2. And then we divide by 3/2, which means we multiply by 2/3. Then we add on a constant of integration. And then we want everything in terms of x. So remember, u was x cubed minus 2. So we get 2/3 times x cubed minus 2 to the 3/2 plus some constant of integration, c. And then one more example before we end the video. Let's look at the integral of minus 4x divided by 1 minus 2x squared, that whole thing squared. So as always, we want to begin by getting everything in one line in nice exponential notation. So this becomes the integral of 1 minus 2x squared to the negative 2. Let me rewrite this to make it nice and neat. 1 minus 2x squared to the negative 2 times minus 4x dx. So pause and ponder what here should be our u and then what leads to our du. Well, here we want to let our u be 1 minus 2x squared because the derivative of 1 minus 2x squared ends up being minus 4x, which is what we have here. So that means that du equals minus 4x dx. We just multiply both sides by dx. And so we have a minus 4x dx right here, which is really handy. So this integral here becomes the integral of u to the minus 2 du. And now because our variable and our variable of integration are the same, we can just apply our standard power rule. And so we have the integral of u to the negative 2 du becomes u to the minus 1 times 1 divided by minus 1 plus some constant of integration, which this is just minus 1 over u plus c. And remember, u is 1 minus 2x squared, so you have minus 1 over 1 minus 2x squared plus c.